You know, deep in the cold, unforgiving vacuum of space, there is a silent war raging right now. Our sun, it's basically a thermal nuclear beast, and it is screaming at us. It's firing this relentless, invisible stream of high-energy, charged particles straight at our planet at literally millions of miles per hour. It's an onslaught that never stops, just a massive cosmic barrage that threatens to strip our atmosphere right down to the bone. Which, of course, forces us to ask a pretty terrifying question. What actually happens if Earth's invisible armor fails? What if this protective layer, something we can't even see with our own eyes, were to just suddenly collapse under the immense pressure of a violent solar storm? Well, make no mistake, without this shield, our thriving green and blue Earth instantly becomes a barren, irradiated wasteland. I mean, the solar wind would just mercilessly strip away our atmosphere. Life as we know it would absolutely cease to exist. But our survival hinges on this invisible force field, and humanity is no longer content to just stay in the dark. So, welcome to this explainer. Today we are exploring a groundbreaking, totally visionary mission that's finally shining a light on this invisible battlefield. We're diving into SMILE, and how exactly it's going to reveal Earth's hidden shield. Just look at this headline for a moment from South China Morning Post. This is the news behind today's video. SMILE in space. China-EU joint planet defense satellite defies earthly tensions. Launch of satellite to study Earth's magnetic shield hailed by lead scientists as a result of true 50-50 collaboration. With that said, let's go straight to the intro. The algorithm buries channels that show the truth like mine every single day. The only thing that fights back is you. One like, one subscribe, turn on the bell icon. That's how the truth about China survives on YouTube. Don't let it disappear. Thank you very much. Okay, part 1, the invisible shield. Let's dive right into this. The European Space Agency frames the stakes perfectly here. They say, for almost 4 billion years, Earth has been holding up a giant shield against the relentless attack of charged particles from the sun. I mean, just pause and think about the sheer scale of that for a second. Since the dawn of single-celled life, this silent guardian has basically stood between us and total annihilation. We call this silent guardian the Magnetosphere. So, what is it? It's a vast magnetic field, generated thousands of miles beneath our feet by oceans of superheated, swirling molten iron, right in Earth's core. And this field projects way out into the darkness of space, forming this giant protective bubble around us. When the brutal solar wind slams into this bubble, all that deadly radiation is deflected away, keeping our fragile little surface safe and sound. But here is the massive, kind of chilling problem. For decades, we have been effectively blind to our own shield. Sure, we've sent probes right through it, capturing these tiny localized data points. We've basically been studying individual trees, but completely missing the vast forest. We have never, ever possessed a complete global picture of how this entire bubble reacts to in real time. Until now, which brings us to part 2, the SMILE mission. Meet SMILE. That stands for the Solar Wind Magnetosphere Ionosphere Link Explorer. And this isn't just another satellite, guys. It is a visionary landmark operation launched to solve a mystery literally as old as the Earth itself. SMILE is engineered to do what we honestly thought was impossible, to step way back into the void and actually image the entire magnetosphere at once. It's taking the invisible and making it visible. And what's really interesting about these mission parameters, sourced straight from ESA and the Chinese Academy of Sciences, is that the sheer scale of this thing becomes super apparent. Launching on May 19, 2026 aboard a Vega-C rocket, SMILE is carrying a massive 2,250 kilograms of highly sensitive equipment up into orbit. This 3-year mission is a seriously heavy-duty commitment to unlocking our planet's deepest defensive secrets. And what makes this even more remarkable is the unprecedented unprecedented alliance behind it all. This represents a historic, full life cycle collaboration between Europe and China. They're sharing the risks and the achievements totally equally. ESA provides the payload module, the launch vehicle, and the tracking, while CAS delivers the satellite platform, mission ops, and ground support. It is a true bottom-up paradigm of international science diplomacy, literally uniting to protect humanity. Moving on to part 3, the science arsenal. Let's look at the tech. To actually make the invisible visible, SMILE is carrying a totally integrated system. It's comprised of 4 highly advanced payloads. We've got the soft X-ray imager, the ultraviolet imager, the light ion analyzer, and a high-precision magnetometer. Together, these instruments don't just passively measure the void. They actively map and visualize the shifting boundaries of our magnetosphere in ways we've never even attempted before. So the crucial point here is how these instruments actually operate. Take the ultraviolet imager, for example. It's designed to stare down at the Earth and observe the northern lights non-stop for up to 45 hours at a time. I mean, that is an absolutely staggering record. We haven't had this kind of continuous, unbroken view of the auroras since way back in 2008. By utilizing the soft X-ray imager to trace exactly where the solar wind violently impacts our magnetic field, and simultaneously using the ultraviolet imager to record the resulting auroras flashing at the poles, we get a first ever simultaneous view. For the very first time in human history, we can basically read the real-time story of Earth responding to a solar onslaught. We are going to witness cosmic cause and effect exactly as it happens. Alright, part 4, an extreme orbit. To capture that entire forest of the magnetosphere we talked about, SMIL gets placed into a highly extreme elliptical orbit, and this brilliantly illustrates how it works. At its apogee, which is its furthest point, it retreats to a staggering 121,182 kilometers above the North Pole just to get a super wide shot of the shield. Then it aggressively swoops into a perigee of just 5,000 kilometers above the South Pole, zooming in close enough to quickly and securely blast all that precious data right back to us on Earth. It takes roughly 52 hours for the spacecraft to complete just one of these massive, looping gravitational slingshots. And because it spends the vast majority of that time hovering way up high near the apogee, it maximizes the window for continuous, uninterrupted observation. It's literally staring down at the northern hemisphere in the dark for almost 2 straight days per orbit. Which brings us to our final section, part 5, next steps in space. Here is exactly how this whole mission is going to unfold. Following that fiery launch on May 19, 2026, the spacecraft spends 26 incredibly tense days executing highly precise orbital maneuvers. That's followed by a rigorous 2-month commissioning phase where engineers carefully test and calibrate that onboard arsenal. And then, by September 2026, SMIL officially goes to work, kicking off 3 solid years of routine, non-stop scientific observation. And here is exactly why this matters to every single one of us. All of this hard-won scientific data will be openly shared with the global research community. By finally understanding the deep, hidden mechanics of solar storms, we are going to dramatically revolutionize space weather forecasting. This means we can secure our skies, we can protect astronauts in orbit, save vital communication satellites from just being completely fried, and safeguard the vulnerable terrestrial power grids that literally run our modern world. It all brings us to a profoundly comforting realization. The invisible armor of Earth is no longer a complete mystery. Thanks to this mission, we've moved from a place of terrifying unknowns to a brilliant scientific triumph. Yes, the silent war in space is still raging, but for the first time, we can finally see the battlefield. Which leads me to a final thought I want to leave you with today. As this incredible international collaboration finally decodes our magnetosphere, what's the next great space mystery we'll illuminate together? I mean, what else is hiding out there in the dark just waiting for humanity to turn on the lights? Let me know what you think in the comments below. And always, stay curious. Thank you so much for joining me on this explainer. Keep looking to the stars. Goodbye.